Okay, so in this question, two functions are given, fx and gx, right? So now obviously you can see this is going to be fx function, right, which is going to be 2 sine x, and obviously this one is going to be your gx function. That gx function is, so gx is going to be half sine 2x, right? So now we know one thing. We know that if you have sine x, right? So this is 0, this is pi, this is 2 pi. So this is sine x. So what if you integrate 0 to 2 pi sine x dx? You get 0, right? So that means this is considered to be plus, this is considered to be minus. So the plus area is going to cancel with minus area. So if you want to catch the area cannot be minus, obviously. If you want to catch the right area, so what you typically do is, this is your area, right? What you typically do, 0 to pi sine x dx, right? So you need to find the total area. Total area means this part over here, and then you have to multiply this by 2, because you found this guy over here, and then you multiply by 2 to get the lower part. So this is positive, so area should be positive. So this construction is wrong, right? So this is the right construction. So I think this can be useful in this question. Okay, now let's look at this, the total area of the shaded region. Okay, so now you can see this is the positive, this is the negative, right? So now they both nullify each other. Why? Because here you don't have a shaded part, here you have a shaded part. So what we can do, we can sort of cut this section and then put it here, paste it in here, then you get this whole area. So you get this whole area, right? Whole area. So we don't have this part. So what you can do, simply you can consider this fx function from 0 to pi, and then when you integrate you get this part, right? And that's positive. Now to get this negative part, it's the same thing. You can see the symmetry. To get this one, what you do, once you find the area of this guy, you multiply this by 2. So that's the strategy. So if you do that, okay, so area total, right? So area total is equal to 2 times. Why? Because you have 2 sections, this one and this one. Okay, 1, 2. Okay, so now to find the area of the first section, right? So that would be integrate 0 to pi. That function is 2 sine x. So 2 sine x dx, right? So if you do that, you can take 2 out, so it's going to be 4. So it's going to be 0 to pi sine x dx. Okay, so that's pretty cool. And then if you observe with this one, so you can directly understand a is going to be 4. Okay, cool. Okay, so moving into the other section, fx is equal to 2 sine x. So we are not going to change that function, so that is fx over here. Okay, so hx, so it's a new function, 1 divided by 3 sine 3x. So we'll try to find out the period of this one, right? So period of this one should be 2 pi divided by 3, right? And the amplitude is going to be 1 divided by 3, right? So that's the amplitude. So this is the period. So what we can do here, right? So now it should look like this. If we plot that, right, and that continues to the other side as well. So it looks like this. So amplitude part is going to be that, right? So this is your amplitude now. Right. So that's hx. So that's hx, which is 1 divided by 3 sine 3x. Okay, cool. Now let's go into this one. State the sequence of transformations that maps the graph of y is equal to fx to the graph of y is equal to hx. Okay, so we'll go with the fundamentals now. Fx is equal to 2 sine x. Okay. Fx is equal to 2 sine x. And hx is equal to 1 divided by 3 sine 3x. Okay. So now, so it maps, right? So the fx maps to hx, yes. So that means I can take this one as y. So I'm going to divide this by 2 as well. So it's going to be sine x. So finally we are going to compare. So this is y prime, y because that's the image. And then I'm going to put 3 here. So I sort of cross multiply here. So it's going to be sine 3x prime. Okay. Now, yeah, so what we are going to do now is we compare. So we compare this guy with this guy and then these two. So if I do that, I get y prime to be y divided by 6, right? X prime to be x divided by 3. Okay, so we judge from these two. So we are going to now write the sequence of transformations. So based on these two informations we have obtained. So the first one would be dilation from x-axis by the factor of 1 divided by 6. So it's involving with y. So that's dilation from x-axis by the factor of 1 divided by 6, and that is straight away coming from here. Yeah. Second one. Okay, so now that's from y-axis, right? So it's going to be dilation from the y-axis by a factor of 1 divided by 3, and that is coming from here. Cool. Okay, moving forward. Right, so now kx is equal to m sine x. Okay, qx is equal to 1 divided by n sine x. So m and n are positive integers. M is greater than 2, greater than or equal to. So this is your kx now. This is your qx now. Okay, so your domain is given. So find the area enclosed by the graph of y is equal to kx and y is equal to qx in terms of m and n. If n is integer, m is even. Yep. And here n is odd. Yeah, so n is even. So now how do you deal with this one? Now we have to understand the holistic picture of this, right? So to understand the holistic picture, we will try to understand so what we had before. So if you look into ABC parts, the summary of those 3 parts is this. So we had y is equal to 2 sine x, right? So the other one is y is equal to 1 divided by 2 sine 2x. Okay. Then the next part was y is equal to 2 sine x, right? Then y is equal to 1 divided by 3 sine 3x. Now, if you observe carefully, so these are even numbers, right? So this is odd, right? So that's the odd case and the even case, right? So if you carefully look into this case, so you will observe one thing. So let me draw this first. So you will observe that in the even case, you know, this positive area is going to compensate with this negative area, right? So if you think about the odd case, right? So this is pi over here, right? So this is pi over here. So these two will compensate each other, meaning if you try to find out the area, so those two will cancel each other, but this positive one survive, right? That positive one survives. Now, if you want to find the area, which area we are talking about, this area. If you want to find out this area, right? This area. So, as we discussed before, you can directly say that area is equal to integration 0 to pi, this point is 0, 2 sine x dx. Okay. But in this case, how do you find the area? Right? So in this case, obviously you have to, if you want to find this guy here, if you want to find this guy, then you have to obviously minus that one, right? So how do you find this coordinate over here? So this coordinate is going to be pi divided by 3 in this case, right? So 0 to pi divided by 3. So what you can do to find that area, I would say 1, right? So 0 to 2, 0 to pi actually. 0 to pi, the function is 2 sine x dx, right? So that will give you this whole thing, right? This whole thing. So I'm going to minus this part. Why? Because these two already taken care, right? So I'm going to minus 0 to pi divided by 3. That function is going to be 1 divided by 3 sine 3x dx. So that's it. That's how you do that. Now, in the even situation, we can use this technique for the even situation. For the odd situation, we can use this, right? So that means in the odd situation, what we are changing. So if you read the question, this 2 is changed by m, right? So this 3 is changed by n. This 3 is changed by n, and this boundary also changed by n. Now, in here, this is m, right? So there is no n involvement there. So if you think about that question here, okay, let me go here. So if it is n, if it is m is contributing, only m is contributing there when n is even. So that a can be written as, I'm going to put 2 here. Why? Because there are 2 sides, right? So I just show you only one side here. So this is the first side, and then the second side also there. So that's why I have 2 in front of that, right? So it's going to be 2. Okay, so you are going to integrate from 0 to pi m sine x dx. So that makes sense for the even case, right? So if you do that, you take m out, so it's going to be 2m, right? 0 to pi, right? So it's going to be sine x dx, right? So if you simplify this, you get 4m plus 0 divided by n squared. So you get the answer here. So it's going to be a is equal to 4 and b is equal to 0 in this case, okay? So moving to the odd case. So now odd case we understood in the previous one, right? So area 2 times, because we have 2 sections, right? So now here 0 to pi, right? 2, not 2, m sine x dx minus what I'm doing is I'm just copying this side, right? So this section I'm going to copy. So then minus integration 0 to pi divided by n, right? So this is 1 divided by n sine nx, right? So dx, close it. So now you can put this into the calculator, right? So that would be 4m plus 4 divided by n squared. So from here, a is equal to 4 and b is equal to 4. So that's all about it. So this CAS part is not a big deal. but this construction is important. Construction is important.